Hi, I'm Phil, and today I'm going to talk about Bitcar with microbit. So I'm using a mind map, and starting off at the top right, I'll describe what Bitcar is, what features, the parts that go to make it, some of the software tools that are available for it, and I'll particularly spend time on a course developed by Tinkergen that relates to microbit, and in particular lessons 10 to 12, and I'll extend the course with a couple of projects. I'll look at a critique of it, the pros and the cons of Bitcar, and I'll provide some references. So Bitcar is based on microbit, and it's for STEM education. So it was originally developed by Tinkergen, which was a spin-off of Seed Studio, and it's part of the STEM tools that are available from Tinkergen. So in the kit, you get some components, which includes a car chassis, and that has a buzzer on it with line following sensors. It's got addressable LEDs, and it has an add-on ultrasonics rangefinder. So overall, just under $25. And this is what some of the parts look like. So the chassis comes assembled already for you with the motors on board. So you just plug in the battery holder, and it's got line followers. So there's only two line followers, one for the left and one for the right. And for software, you can either use Makecode, or from Tinkergen themselves, they have Codecraft. So if you've got other Tinkergen products or seed products, there's quite good support for Codecraft. And Bitcar is one of the items that is supported by Codecraft. But for the project that I'll be talking about, I'll be using the Microsoft Makecode editor. And for Makecode, there are extensions available, blocks that you can put together yourself that can drive Bitcar and its accessories, like the line follower, the ultrasonic sensor, and you can also use the NeoPixel blocks. And this is what Codecraft looks like. And again, you get plenty of support using this platform. So the Tinkergen course, lessons 10 to 12, provide quite good support for Bitcar. And you can access it via Codecraft help. You can get the lessons from that. So my project will be an extension of lesson 12. And what I intend to do is to create two modes for Bitcar. One's an automatic mode, and you can select automatic or manual from a remote control player called the BitPlayer. So under automatic, the Bitcar will follow the line, and it will do obstacle detection and avoidance. In manual mode, BitPlayer will control all the movements, and I'll provide plenty of support using feedback and minimize any latency that might cause. Also, I want to provide a bit of safety so that there's emergency stops, and these can either be accessed by pressing the microbit logo, pressing buttons A and B together, or shaking BitPlayer. So also want to explore some alternative ways of controlling. So I'll be using the accelerometer on microbit. That is the microbit on BitPlayer. So if I move it to the left, then I can steer left, or if I move it to the right, I can steer right. So I want to provide some feedback to the user. I'll utilize the vibration controls on BitPlayer. I'll use the microbit LED array. And when I do that, I want to make sure that I don't scroll across, because that's going to delay the carrying out the commands. So for hardware, I've got microbit, and there'll be two of those. One will be on Bitcar, and the other microbit will be on BitPlayer. So that means each microbit has its own code, and these are the extensions and the blocks for each software module. And to control the car, this is what the overall program looks like. So I'll go in detail on each of the blocks, but basically starting off on the left, we've got the startup, followed by the forever loop. And in the middle, we've got the radio received module, which processes the command sent by BitPlayer. And on the right, we've got the manual mode function. And this is where we call other routines, either say for flashing the LEDs, checking turns. And on startup, we set the radio to group 1. And that has to also be set up on the BitPlayer software. The other software is looking at setting up the NeoPixel strips, including subdividing that to the left and the right, putting it initially into auto mode control, and setting up a manual command, which can be anywhere in the array of 1 to 16. So instead of actually showing numbers greater than 10, I'll use hexadecimals to minimize the time needed for scrolling 2 digits. So here I've got the forever loop, and if it's in auto mode, I will do line following. And with the extensions for Bitcar, all you need to do is just provide a single command for doing that. And there are the other functions that I'm calling checking turns and checking the distance. If I do put on the red lights, I want to flash those at half a second interval. So for receiving the radio command, if it's number 15, that's an emergency stop, and I'll immediately turn off the motors. Otherwise, the number received is sent into the manual control or the manual command variable. Here's where I check the turns, and if I turn left, I put on the left LEDs and show those to be white. Alternatively, if it's right, I'll show the white on the right LEDs. Here's the manual mode processing. Again, with emergency stop, which is a manual command 15, I will turn off the motors. Otherwise, I will call the turns. And here's where the code for the BitPlayer comes in. So I'm either checking the joystick in the forever loop, or I've got event processing happening when I press any of the keys, A to D, or the left or right buttons on BitPlayer. So here's on BitPlayer where I'm starting up and doing some event processing. If I tilt microbit left or right, shake it, or press the logo. So if I want to do an emergency stop, either that can happen by pressing buttons A and B, pressing the logo, or shaking microbit. In the forever loop, I'm just simply sending commands via microbit radio, depending on what joystick position I've selected. And here's where I process the other keys and show on microbit the arrows north, south, east, or west, depending on which movement I want Bitcar to follow. And there's a separate video in higher resolution available to have a look at the movements of Bitcar, controlled by BitPlayer. So overall, I got good results. I was able to reduce the latency from 3 seconds down to about 1.5 by minimizing scrolling on the microbit. Lots of future projects. So the keys at the moment are providing redundant commands on BitPlayer, and I can redeploy those keys for future projects. Some of the limitations, there is only really one Grove port available, and that's an I2C port. The other port, you can get access to it. It's on pins 1 and 2, but you have to remove some resistors on the chassis of Bitcar. But what can you do with the I2C port? Well, you could put a temperature or an environmental sensor and scan the microclimate in the area. You could put a UV sensor on, or better still, if you wanted to do some artificial intelligence with a camera, you could use the Husky lens from DF Robot, which is both UART and, more important for this project, or for Bitcar, it also supports the I2C port. Another future project would be coupling the microbits or the Bitcar into a tram. And there'd be two controls. So this fast control using a PID algorithm to minimize the separation and couple the cars together using the ultrasonic sensor, but also using microbit radio, bearing in mind that you're going to get a little bit of latency over that. Other projects might include finding out where you are on the map and a bit of location detection, perhaps using a barcode reader or an RFID reader with tags on the robot. And I also want to do a bit of concurrent programming, that is by putting in 2 forever loops and not only processing the movements, but also processing some of the other functions like lights on Bitcar. So overall, I think Bitcar is quite good value for money, bearing in mind for $25 US dollars, you get quite a good package. There's excellent motors and control, reasonably easy to assemble, and you can complete the assembly easily within 1 hour. There's excellent course material available from Tinkergen, and it's quite a good introduction into robotics with good support from Makecode with extensions, or alternatively using Codecraft. Some of the cons, I was a bit disappointed that while there are 2 Grove ports available, one of those ports is pretty useless, particularly if you want to use the line following sensors. And that means that I can't use my Grove UART sensors, such as machine vision sensors. But one possibility is to use the I2C Husky lens available from DF Robot, and it has Makecode support. I was also disappointed in that 30% of the kits that I purchased all had defects. And I'm now addressing that issue with Seed Studio. The Tinkergen wikis have disappeared, but you can still get access to the tutorials via the Codecraft help. And there doesn't seem to be much activity over the last couple of years in this area from Seed Studio. So it may not be the best choice if you're looking for a STEM robot kit based on microbit. And there are other alternatives. So if you want to do some machine vision and use a camera to recognize where the line is for line following, or even recognize traffic signals, I would recommend the DF Robot Micro McQueen Plus. Now, while it's double the price of the microbit, it does give you plenty of opportunities for connecting to any of the pins on microbit, and it's got a platform for adding those accessories. So quite a good project, and it's a good starting point for robotics using microbit. Here are some of the references from Seed, DF Robot, and accessing some of the software. Okay, thank you for listening, and that's it for now. Bye.